Hi, my name is Attila, and I'm a PhD student from Umeå University in Sweden, and in our project we reviewed papers submitted to MIDL to evaluate their reproducibility. In the field of medical imaging with deep learning, the papers themselves are not sufficient to ensure reproducibility. So if you would like to implement an approach that you read about in a paper, given the page limitations, it will be impossible using only the text. For this end, public code repositories like GitHub or Dropbox are becoming more and more of a standard, but this shift in how papers are presented wasn't followed by proper support and education on how this material should be structured. And in our field it gets even trickier because of possible sensitive data and the constant competition for state-of-the-art. Our belief is that authors wish to be transparent but often don't know how or why. So we have decided to explore the extent of this issue, and we collect the most common pitfalls when constructing a public repository. And we also present a summary of possible solutions as a set of guidelines. As a more general goal, we wish to provide support for researchers using deep learning for medical imaging and to have a discussion, but for our methodology we will focus mostly on MIDL, a perfect venue for this task. We started with literature review and found other initiatives that aim to improve reproducibility. This is combined with a constant discussion about possible improvements and more practical issues that we might not be aware of. Very insightful results from a poll proposed to the MIDL community showed that although readers often try out public repositories, they very often encounter issues that make the code generally difficult to use. So we set up an evaluation system and went through all of the full papers submitted to MIDL. The first part of our evaluation is based on the manuscript. The first requirement is that the main body of the paper properly explains what material is private and what is available for everyone. Most importantly, is there a publicly available code repository? And if not, then why not? Similarly, the datasets used in the paper should also be addressed. Using public datasets provide an extremely powerful baseline for other researchers, so their use is encouraged and their proper referencing is required. And the same goes for private datasets. Address where they were collected and that they are not publicly available. A popular approach for exploiting private datasets and having reproducible results is using the in-house data for training and evaluating on public data. The rest of the questions regard the code repository if it's available. To run the code from the repository, a list of packages are required to be installed first. This should be easy to access when opening the repository, and it's most often stored in a TXT or a YML file. The next part is the actual code. There should be a file specifically for training, in which the training data is loaded, the model is compiled, and the training is performed using well-defined hyperparameters. Most popular choices are a Python script or a Jupyter or Colab notebook. After training, another file should show how the model can be evaluated. The easiest way to make the model readily available for others is by sharing the trained model used in the paper. This saves a lot of computations, coding, and debugging issues, and it also adds great transparency to the project. Sharing only the model weights allows others to compile the model and keep training, while more open, standalone formats would allow others to make predictions with your model using their data. Additionally, everything described above should be well documented. The dependencies and the code should be easy to find using documentation of the repo. And finally, an appropriate licensing should be included to define how others are allowed to use the code and the model. With these guidelines, we have then evaluated all the submissions since 2018 to see how things are developing. We believe that the code repository should be available by the beginning of the conference, so as of today, 14th of June, we have decided not to include 2023 submissions yet. The use of code repositories and public datasets is increasing, however the quality of the repositories shows no signs of improvement. Almost half of all repositories miss to include the package dependencies altogether, which means that in a few years' time the code will be almost impossible to trace back and get to work. Our metric, called model repeatability, implies that the manuscript has a public repository that contains the dependencies, training, and evaluation code, which is what's needed for the method to be reproducible per se, and throughout the years we report that only 22% of all submissions are reproducible. An average score can also be computed for each submission between 0 and 6 based on how many checklist items they passed, and this metric shows no significant change throughout the years. In summary, we propose a set of guidelines that were adjusted to commonly encountered pitfalls from previous years at MIDL. The guidelines can be split into simple manuscript-specific questions and a set of more detailed code-specific questions. But our project doesn't end here. We are hoping to keep the discussion alive, and we are really interested to see how the results will change for future submissions. Hence, the guidelines are not set in stone. We expect that they will change and adapt over time based on feedback from the community. For transparency, all of our evaluations are available online if you follow the QR code, And if you have any questions or comments, feel free to send me an email or come and talk to me during the conference. And if you're interested in how the 2023 submissions performed, I will share them in our presentation at the conference during Monday's MIDL sessions. Thank you for listening.